Hi, this is a demo video for our embedded systems mini project that we have carried out in this particular course. So project title is onboard diagnostic module. So I am Girish and my member Saurish, we have worked in this thing. So the project consists of developing an OBD scanner, so which will retrieve the data from a car and with real-time sensor values. So in order to, instead of getting from a car, we have also developed a car emulator application in Python in order to simulate the data and how this protocol works in a car. So what we have done is like our particular OBD scanner supports three particular modes. Mode 1 reading the real-time sensor data. Mode 3 is checking the diagnostic trouble codes or fault that is present in the ECU memory. Third one is clearing the faults. So the system consists of the system architecture is consist of two things. One is this OBD scanner, which is used to log the data and then show the particular data, and second one is our particular ECU. This DIVA along with the ECU along with the Python application will serve as a car ECU and it will send the data. So the physical layer protocol what we are using for this particular OBD scan, so ISO 15645 Pro standard we are using. So let's see the working. So this car emulator consists of the different dashboards. Like we have taken an example of 5 different codes. One is engine speed, vehicle speed, fuel pressure, throttle pressure and mass airflow. So these particular data can be requested from the OBD scanner what we have developed, and the data will be sent through CAN. And from CAN to application, the CAN frame is stripped out and the data along with the identifier is being sent to the application, and the respective responses will be taken again back, and again the CAN, it will be placed in a CAN frame handler and it will be sent again to the OBD scanner. So let us see the working. So this is our main page. This is our application that we have developed using a touch LCD Kentac QVGA TA compatible display. So this is the PID's process identifier that we can read. So let me just click on this thing. So it shows two different options. One is engine RPM and engine RPM continuous monitoring. So engine RPM, if I particularly press it, so it will pull once the data to the application, and whatever application has the particular data, it will send it back again. So for the ease of monitoring a particular process identifier again and again, so we have provided the engine RPM functionality. So when we are doing engine RPM functionality, the data is pulled again and again in a frame space of 3 seconds. So every request will from one request to another, the time space what we have given is 3 seconds. So let me just change the values here. So say let me change the engine RPM. So you can also see lively in the display. So yeah, so this thing you can also see in the OBD scanner. Let me just change in the emulator. So as you can see, it captures the trend or the real-time data what is being sent to it. So the another important application of the OBD based scanners or OBD protocol is diagnosing the fault. So there are different ways in diagnosing the fault. So there is a different fault life cycle that is being happening. So we have tried to emulate the fault in a interactive dashboard kind of a thing in our car emulator. So what we have doing is like these are the standard for DTC codes that is being available. So which happens, which is being characterized by the international standards. So when I try to inject a particular fault, so what happens is it will get stored as an active DTC. So once that particular fault is being cleared internally, so this particular fault thing goes off. So if the fault, active fault, if a particular DTC code is activated again and again and comes into active DTC fault, so what happens is it will be moved into a stored DTC as a permanent fault and it will be stored in a non-volatile memory. So let me just move some of the PIDs here also. So yeah, 0712. Okay, inject the fault and then move this to. As you can see, now 3 particular codes are being stored in the non-volatile memory of ECU. We are emulating that particular thing. So let us try to read it from our OBD scanner. So in our OBD scanner, what we have designed, we have we will support the mode of checking the DTCs at the max of 3 particular DTCs. So it uses single frame format. So when I press the check DTC, the data, the DTCs what is being set in the non-volatile memory is being reflected here as well. So yeah, so this is the codes for the reference. So another more functionality is the clearing the diagnostic trouble code. So whatever the fault is being cleared in some way, so the non-volatile memory, whatever permanently it has been stored the DTCs, it should be manually flushed by the user. So let us take the clear DTC. So once if I press the clear DTC, the already the set DTC values in the stored DTC will be clear. So let me just press it again. Yeah, so the DTC is being, as you can see, so it has cleared the entries whatever being present in the stored DTC. So this is our project. Yeah.